Hello everyone, and welcome to our video on adding and subtracting matrices, where we'll be focusing on finding variables when we have equal matrices. So to start it off, let's look at some vocabulary. So the rows of a matrix are the horizontal elements. The columns of a matrix are the vertical elements. When I think of these two, I think like the rows of, say, a movie theater are I would say, are probably kind of considered horizontal. And then the columns of, say, a building. Okay, so like some old Greek or Roman structure is kind of what I'm trying to draw there. Okay, so but the columns are vertical, and so that's how I usually try to break it down to make sure I know which one is which. The size of a matrix is the dimensions given as the number of rows by the number of columns. So the size always goes by rows and then columns. I think of RC Cola for some reason. So rows and then columns. And this soda, I don't know if that exists anymore, but if it does, that's great. Maybe give it a shot. Try it out. Okay, so RC Cola, rows and then columns. Matrices are equal if they have the same size and if each pair of corresponding elements is equal. A square matrix is when the number of rows and the number of columns are the same, and it makes the shape of a square. A row matrix is when the matrix has only one row. A column matrix is when the matrix has only one column. So let's look at these four matrices down below, and matrices is the plural of matrix. So let's use some of this vocabulary to say what the sizes are and then note anything that's special about them. So in this first matrix, it looks like we have 2 rows and 3 columns. So the size is a 2 by 3. And that's often how we write it, so that we use the X. It doesn't mean multiply, it does mean 2 by 3. Okay, so you can write it in words if you prefer. Okay, so but it is 2 rows, 3 vertical columns. Okay, so that's the size, and then that's it with this one. There's nothing else special about it. It's not a square, column, or row matrix. Okay, so moving on. Number 2, here the number of rows and the number of columns are the same. So this is a 2 by 2. And then because it is the shape of a square, it is a square matrix as well. And then for number 3 here, well, it looks like there's 1 row only. There are 2 columns, so the size is 1 row by 2 columns. 1 by 2. And then this would be the example of a row. There's only a single horizontal row that's important to us. So that is a row matrix. So if they want that vocabulary, there we go. And then our fourth one here, well, this is having 3 rows and 1 column. So 3 rows by 1 column is the size. And then this is one of the special ones. This is a column matrix because it only has 1 column. Okay, and so it is just kind of 1 vertical pillar is kind of another way to look at it. Okay, so there's some of the vocabulary. So this is just identifying certain things. Now let's use the equal part of the vocabulary to solve some of the problems that they want us to solve here. So in this example, it says find the values of the variables in each equation. So notice they did an equal sign to show that this matrix is equal to this matrix, and all we have to do is just note, well, we just need to make sure the corresponding elements are equal. So it starts off saying 6 is equal to 6, yep. And then let's move on, let's use some colors. This 4 needs to equal 2x. Okay, so let's just set that up. So 4 equals 2x. And then while this is easy to solve, we could just divide by 2. I'm going to put the x on the left side. X would be 2. And then that would be giving us 4 equals 4 for those corresponding elements. And then our bottom left one, okay, so we've got -2 equals 4y. All right, so we'll just set that up also and solve. Here, let's go ahead and show the division. So we would need to divide by 4 to get y by itself. And then from here we could state, well, -2/4 would be -1/2 reduced. Okay, so there's that one. And we could always check it, like if we multiply 4 by -1/2, it does match with the -2 on the left side. All right, one more. I'm kind of out of my pin color, so I'm just going to highlight those ones and state, well, this 1, it needs to equal that -3z. And well, we could solve this if we divide by -3. And that gives us our z all by itself. Z would equal -1/3. And again, we can kind of quickly check it. If you plug in -1/3 into that z right there, it would give us +1, which matches its corresponding element. So there we go. That's it. Okay, so it really just becomes a bunch of small solvable equations separated as we do our equal matrices. All right, for number 2, this is, okay, if they did say just for a little bit more practice on the size, this has 2 rows and 3 columns. So these are each 2 by 3. So that means they are equal. They are the same size. And from here, we're just going to make sure we match up the corresponding elements, and then we'll solve. So for instance, let's go ahead and just, I'm going to number it for this one. So 3x minus 1 would need to equal 23. And then from here, it's solve the equation. So we'll add 1 to both sides. So we'll have 3x equals 24. And then we can divide by 3 to get our final answer for just the x. So we've got x would be 8. Got it. Okay, moving on. Okay, so let's use some colors again. So this 2y plus 4 needs to equal the -30. So this is our second one. So 2y plus 4 needs to equal -30. And then, well, let's go ahead and solve it. So we would need to subtract 4 on both sides. And then we would have 2y equals -34. Dividing by 2 gives us our final answer for y is equal to -17. And there we go. Okay, so there's y. Our next one is already, I'm just going to do a check mark. 8 equals 8, that's true, so there's nothing to solve for, so we just move on. And I'm going to do it in purple. I've got 10z would need to equal -75, so that's the third thing we need to solve. So 10z equals -75. Dividing each of those by 10 would give us, and I'm going to keep it as a fraction, z equals negative. Each of these is divisible by 5, and it would look like 5 would go into the top 15 times. 10 divided by 5 is 2. And you could always use decimals too, unless they restrict it to fractions. But we can convert those as well using our calculator. Okay, so that's our third one. Let's keep it going. All right, so it looks like we've got, so I'm going to go to highlighter now since I've used my colors. So here's our fourth thing to solve. And then, well, that is already solved. So I will just number it number 4 still and say, well, -4 is equal to t. There's nothing to, it is solved for us. Cool, so we don't have to do any extra work. And then our last one, let me use my other color that I have. We're saying those two must be equal. So then our fifth thing to solve in this would be setting w minus 1 equal to 2w minus 9. All right, and then to solve this, let's go ahead and do 2 steps in one. I'm going to add the 1 over, and at the same time subtract the 2w over. And then that way, I would have w minus 2w is negative w, the 1 0 out, equals the 2w 0 out, and it looks like I have negative 8 left over on the right. And then we would need positive w, not negative w, so we can multiply both of these by -1 to make them their opposite signs for the final answer for the w portion. So w would be 8. And that's it. We're done. Okay, so that's how we can set these up. So if they give us equal matrices, so they like to do this before we get to the actual addition and subtraction. That will be in the next video. We will put a pause on it. But it is just break it into pieces. Just slowly go at it. Okay, so we can't really do this all in one giant step. So just take your time. All right, well, anyway, if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.